Hey students, in this lesson we're going to cover the half angle formulas for sine, cosine, and tangent. For each of these formulas we need to know the cosine value, and for the half angle formula for tangent we also need to know the sine value. Where the half angle is located is dependent upon the whole angle. In the example above in the paragraph we have if theta was 210, half of that is going to be 105. So our angle would be in quadrant 2. So sine would be positive, and then cosine and tangent would be negative. So let's get started with using these formulas. For example 1, we have to find the exact trigonometric values for 165 degrees. So the sine for 165 degrees according to our formula is going to be the square root of 1 minus the cosine of the whole angle, which is 330 degrees, divided by 2. So remember, for 330 degrees, the reference angle is 30 degrees. Cosine is positive in quadrant 4. So we expect to get the square root of 1 minus the cosine of 330 is the square root of 3 divided by 2, and all of that is going to be divided by 2. If we get a common denominator, we would have the square root of 2 minus the square root of 3. All of that would be divided by 2, and all of that is divided by 2. So we end up with the square root of 2 minus the square root of 3 divided by the square root of 4, but we're just going to put a 2 because we multiply the 2 and the 2 and get 4, but then the square root of 4 is 2, so this is our final answer for the sine. For cosine, we're going to get the cosine of 165 degrees is basically the same formula except for plus, so 1 plus cosine 330 degrees divided by 2, which is, all right, so in this case it's going to be negative because in quadrant 2 cosine should be negative, so we're going to have minus square root of 1 plus square root 3 divided by 2, all divided by 2. In a similar step, we get a common denominator of 2, so we get the square root of 2 plus the square root of 3 divided by 2 divided by 2, which is going to equal the square root of 2 plus the square root of 3 divided by 4. And the step I didn't take in the last problem, for sine, was when we have the square root of a fraction, you can do the square root of the numerator divided by the square root of the denominator. So that's how we get the square root of 2 plus the square root of 3 divided by the square root of 4, which is 2. And so then for tangent, we have the tangent of 165. I forget these formulas myself. There's so many of them. I'm pretty sure it's cosine, 1 minus cosine divided by sine. So we get 1 minus the cosine of 330 degrees divided by the sine of 330 degrees. And that is 1 minus the square root of 3 divided by 2 divided by the sine of 330 is negative 1/2. So really we're multiplying by negative 2. So negative 2 times 1 minus the square root of 3 divided by 2. If we distribute, that is negative 2 plus the square root of 3. And that is a negative value, and tangent should be negative in quadrant 2. So that is how we use the half angle formulas. So generally speaking, you have to either be given a special angle, and then you divide it by 2, and you use the sine and cosine values of that special angle, or you just have to be given the values for whatever angle you want to divide by 2. So in our second example, we're going to solve an equation using a half angle formula. So we have 2 plus sine squared theta equals 2 sine squared theta divided by 2. So in our rewrite, we're going to replace what I just underlined, the sine squared theta over 2. Remember, sine theta, or half of theta, is the square root of 1 minus cosine theta divided by 2. So in our formula, in our equation, we're going to get 2 plus sine squared theta equals 2. And so then in the place of sine theta over 2, we're going to put the square root of 1 minus cosine theta all divided by 2 squared. All right, I'm sorry I wrote in that, but that's just going to be squared. So we'll put a square right here. So that's going to be squared. So in our next step, we get 2 plus, so we'll just keep the sine squared. We're going to take it out in a moment. So 2 plus sine squared theta equals, when we square that square root, we're just going to get the square root. So 1 minus cosine theta divided by 2. But then when we distribute the 2, the 2's cancel. So we have just 1 minus cosine theta. And then we want to, since we have this trig equation where we have sine squared and cosine, we all remember from lesson 1, we want to get that down to a single trig function. So we're going to replace sine squared theta with 1 minus cosine squared theta. So we get 2 plus 1 minus cosine squared theta equals 1 minus cosine theta. And remember, to solve a trig equation, now we need to move everything to one side. So we could get 0 equals, so 2 plus 1 is going to be 3. If we subtract 3, that's going to give us, so we're going to add the cosine squared. So we get cosine squared theta minus cosine theta. And so this made a positive 3. When we move it over here, we have to subtract 3. So we get minus 2. And so now from here, we can factor this. This is going to be, how do you get cosine squared? You multiply cosine theta by itself. So cosine theta times cosine theta. Then the factors of negative 2 that give you a negative 1 in the middle are going to be a minus 2 and a plus 1. And so this equals 0. So the first equation implies that cosine theta equals 2, because we take this equation, set it equal to 0, which means cosine theta equals 0. For this one, we get no solution. Because remember, cosine is a value that's between negative 1 and positive 1. And so then for the other, we get cosine theta equals negative 1. If we apply inverse trig function, theta is going to equal cosine inverse of negative 1. And on the interval 0 to 2 pi, the only time that happens is when theta equals pi. So that's it. We use the half angle formula to turn into just sine, in this case, 1 minus cosine theta, and then we use what we learned in lesson 1 to solve the rest of the equation. For example 3, we are given the cosecant value of theta, and we need to find sine theta over 2, cosine theta over 2, and tangent theta over 2. Now what's key here is that theta is between pi and 3 pi over 2, which means that if you divide that by 2, then pi over 2 is less than theta over 2, which is less than 3 pi over 4. So the angle is between 90 and 135 degrees, which again is going to mean that sine is positive and cosine and tangent are negative. Now the reason that cosecant theta equals negative 17 over 8 is relevant is that, one, we know theta is in quadrant 3 because we're told that right here. So if we draw our angle, so we get this angle over here, we're cosecant. So remember, cosecant is the hypotenuse divided by the vertical side. So the hypotenuse is 17 and the vertical side is negative 8. Or the opposite if you want to think about it that way. So what we need to find is the x value. So if we have, we'll say like x squared plus negative 8 squared equals 17 squared. And so that's x squared plus 64 equals 289. So x squared plus 64 equals 289. X squared is going to equal 225. And so x is going to equal plus and minus the square root of 225, which is plus and minus 15. Since the x is negative in quadrant 2 and quadrant 3, we're going to say x is negative 15. Now, the reason we need to do this is for the half angle formulas, we need the sine and cosine values of theta. So we already know if cosecant theta is negative 17 over 8, then sine theta is just the reciprocal, negative 8 divided by 17. We also know now that the cosine of theta is negative 15 divided by 17. Because it's adjacent over hypotenuse. All right, so now we can do our half angle formula. So the sine for theta over 2 is equal to the square root of 1 minus cosine theta, which is negative 15 over 17. So 1 minus negative 15 divided by 17, all divided by 2, which, if we get a common denominator, that's 17 plus, that's going to equal 17 plus 15 divided by 17, all divided by 2. And that is 32 divided by the square root of 32 divided by 34, which, 2 divides into both of those. So the square root of 16 divided by 17, which is 4 over the square root of 17. Or you could also tell me 4 square root 17 divided by 17. Now, there are two ways to do this from here. You could either make a right triangle out of the 4 root 17 over 17, where you have the opposite is 4 root 17 and the hypotenuse is 17, and then solve for the other side and use that as your adjacent and get cosine. I'm just going to do the formula as if you just had to find cosine theta over 2. So cosine theta divided by 2 is going to be the exact same thing, except we're adding in this case. So the square root of 1 plus cosine theta, so 1 plus negative 15 divided by 17, all divided by 2. And instead, we're going to get the square root of 17 minus 15. So 17 minus 15, all divided by 17, all divided by 2, which is the square root of 2 over 17 divided by 2, which is the square root of 2 divided by 34, which of course simplifies to be the square root of 1 divided by 17, which is just 1 over the square root of 17, or root 17 over 17. So again, however you get there, but that's what we would do. And so then finally for tangent theta over 2, let me see if I have room. So the tangent of theta over 2 is equal to 1 minus cosine theta, which we already know is negative 15 over 17, divided by sine theta, which was it negative 8 over 17? So divided by negative 8 over 17. So we get same thing. So 17 plus 15 over 17 times the reciprocal of this, which is 17 divided by negative 8. And that's going to equal the 17's cancel. So we get 32 divided by negative 8, which is negative 4. We could have also gotten that from doing the sine theta over 2 divided by cosine theta over 2. We also would have gotten 4 that way. We could have done 4 square root 17 divided by 17 divided by the square root of 17 divided by 17. The 17s would cancel. The square roots of 17 would cancel. And we also get 4. Oh, you know what? Actually, one of those should have been negative somewhere along the way because it's in quadrant 2. So that should have been negative, and that would have made that one negative because cosine and tangent are both negative in quadrant 2. So now, for example 4, we just have to, what we're basically given is the right side of this half angle formula. So we have to figure out what the left side would be. So if we here, when we see a minus, that's going to indicate that it's the sine of a half angle. And all we need to do is divide that angle by 2. So this is the sine of 5x. So now if we, just so you can see this, if we put that into the formula, it would be 1 minus cosine of 2 times that angle, which would be 10x divided by 2. So those two things are true. So when we see the plus, that's going to indicate that it's the cosine of a half angle. So we're going to get cosine divide the 8x by 2. So we get cosine 4x. It's that simple. And then for option C, we have 1 minus cosine 4x. So, and divided by sine 4x, that's an indicator for a tangent of a half angle. So this is going to be tangent 2x. And we even have a formula for tangent 2x. We're not going to turn it into that. We're just going to simplify it to be this. So given one side of an expression, if it looks like a half angle formula, just divide the angle by 2 and apply either sine, cosine, or tangent based upon the square root or how the fraction is set up. So then for example 5, which I think is the last one for this lesson, is we have another half angle that's in radians, 3 pi over 8. So in this case, the first thing that we want to do is figure out what the whole angle is. So what we know is that theta divided by 2 is equal to 3 pi divided by 8. So obviously we can multiply both sides by 2. So theta is going to equal 3 pi divided by 8 times 2, which is 3 pi over 4. And we know that angle is in Q2. So if 3 pi over 8, so 3 pi over 4 is 135 degrees. So then 3 pi over 8 is 67.5 degrees. So that's in quadrant 1. All of the trig values should be positive. So we're going to say the sine of theta, So the sine of 3 pi divided by 8 is going to equal the square root of 1 minus cosine 3 pi over 4 divided by 2. So the cosine of 3 pi over 4 is negative square root 2 over 2 because cosine is negative in quadrant 2. So we get the square root of 1 minus negative square root 2 divided by 2, all divided by 2. And so when we simplify this, again, the 1 is 2 divided by 2. So we get the square root of 2 plus the square root of 2 divided by 2, all divided by 2. So simplified, we get the square root of 2 plus root 2 divided by 4, which if we further simplify, we get the square root of 2 plus the square root of 2 divided by 2. That's our final answer. And so then over here, let me write cosine. So have some space. We'll section this off. So we get cosine of 3 pi over 8 is the square root of 1 plus the cosine of 3 pi divided by 4 divided by 2. So we get the square root of 1 minus square root 2 divided by 2. Again, because cosine 3 pi over 4 is negative square root 2 divided by 2, all divided by 2. So when we simplify, we get 2 minus root 2 divided by 2, all divided by 2, which gives us the square root of 2 minus root 2 divided by 4. And finally, that simplifies to be, take that back, the square root of 2 minus root 2 divided by 2. And finally, for tangent, we could, just so you can see how this actually looks. So the tangent of 3 pi over 8, we can just do the sine of the half angle and cosine of the half angle. So that could be 2 plus root 2 divided by 2. That is the sine, and cosine is 2 minus root 2 divided by 2. I'm sorry, that should be in the square root. That should be in the square root. So the 2's cancel. So we end up with the square root of 2 plus root 2 divided by the square root of 2 minus root 2. So now that looks complicated because you'd have to like technically rationalize the denominator, where you would have square root of 2. We're not going to go there. We could just multiply by, so you know what, actually, so we'll have the square root of 2 minus the square root of 2 times the square root of 2 minus the square root of 2. In the numerator, we would get the square root of 2 plus root 2 times 2 minus root 2, all divided by, so in the denominator, we're just going to get 2 minus the square root of 2. Cool. And then that would simplify to be the square root of 4, the square root of 4 minus, so 4, then 2 times negative square root 2 and 2 times positive square root 2 cancel. So then root 2 times root 2 is just going to be minus 2, all divided by 2 minus square root 2, which is the square root of 2 divided by 2 minus square root 2. So we could do that if you wanted to just use the sine and cosine values of the half angle. But in my opinion, generally what's simpler is to just use the formula. So the other way is tangent 3 pi over 8 is, 1 minus cosine, cosine 3 pi over 4. 1 minus cosine 3 pi over 4 divided by the sine of 3 pi over 4. So that would be 1 plus the square root of 2 over 2 divided by square root 2 over 2, which would be 2 plus root 2 all divided by 2 divided by the square root of 2 over 2, and that would be 2 plus root 2 over root 2. So if you rationalize this, you would get this, but just trust me when I say it's not worth the effort. So the simpler version is this. These are the same number. Believe it or not, they are the same value. So anyway, that concludes our video on half angle formulas. A little bit longer than I expected, but all you have to do is remember those 3 formulas or look them up, and you will be good to go. Thanks for watching.